Okay, hi everyone. Today we are going to solve this LeetCode problem 907 sum of subarray minimums. This is a very decent problem. It has a good like to dislike ratio and it's a medium problem. So we're given an array of integers array. We need to find the sum of minimum b where b ranges over every contiguous subarray of the array. Since the answer may be large, return the answer modulo 10 raised to power 9 plus 1. Fine. So this is not a very good explanation in my opinion for a problem. I will try to explain you the problem first and then we will jump on the solution part. So we have the array as 3 1 2 and 4, right? This is the array and the indexes are 0 1 2 and 3. Now we need to construct all the subarrays, and from these so the question says that we need to construct all the subarrays. Not construct, actually it means that the minimum value of all the subarrays should be added together. So from starting from 0th index, the subarrays that I can have is 3 3 1 3 1 2 and 3 1 2 and 4. Starting from first index, the subarrays that I can have is 1 1 2 1 2 4. Starting from second index, we can have the values as 2, then we have 2 4, and starting from third index we have the values as 4 only. Now the minimum values from these subarrays would be, we will have 3 from this subarray. From this subarray the minimum will be 1 obviously. From this subarray 1 again and 1 here as well. This is 2 and this is 2 again, and we don't have any other element than 4, then 4 is the minimum element. So now if we sum all these elements, so this will be 3 plus 1 4 5 6 7 8 9, this is 11 and this is 13 and this is 17. 13 plus 4 17. So 17 should be the answer and it is the answer, and this is the way how we calculate this answer. So again, now this problem should be solved. Now the solution that naturally comes to our mind is n square solution, not n square, where we find all the subarrays, and first we find all the subarrays and then we find the minimum out of these subarrays, and yeah, and then we find the minimum value out of these subarrays, and that's it. Like, this is the solution, and this solution will easily take n square of time, because the time we are taking to check the subarray or construct a subarray is n square, and we can use the linear search in that part while we are constructing it to find the minimum value. But obviously this problem shouldn't be solved in a n square time, because the constraints that are given to us is 3 into 10 raised to power 4, which means the required time complexity of the solution will be n, right? We need to solve it in linear time. And how to do that, let's see. So first of all, there are quite few important observations that I want you to understand. So first we have this array, right? And these are the index. Now what if I say you that I want to construct all the subarrays that have 1 in them? What will be the answer? So for that part, we can construct a subarray with this part, right? We can have the subarray as 1 only, and we can also have 1 2 1 2 4, right? So you will observe that if we have an ith element, the number of elements or the subarrays, the total number of subarrays will be I plus 1. That means this is the left part of it, multiply by n, that is the total number of elements in the array, minus of I, that is the remaining right elements, and they have to be multiplied in order to get the total number of subarrays, right? So this is the formula. This is a very important formula that we need. But is that it? Like, do you think that this problem is solved? No, it's not solved. Why? Because we cannot form 1 with 3, or we cannot form 3 and 1, right? Because if I say that, let's say construct, now we are going to construct this with 2, right? So if I form, let's say 1 2 4, and we have 2 4, right? I'm making an assumption that we have 2 in this case and it should be a minimum value, so I can include it in my answer. But that's not the case, because in this case it will be 2, the minimum value is 2, but in this case it will be 1. So I need to make some constraints that if I'm taking 2 with myself, if I'm counting how many 2 as a minimum value in these contiguous subarrays will be available, we need to have some start and end constraint. So for example, I cannot take elements that are on this side, and I can take all the elements from this side, right? So this is my start and end constraint. Similarly for 3, now let's say we have 3. For 3, I cannot take elements on this side. Why? Because we have 1 here. Because if I will take 3, 1, or if I will take 3, the minimum value will be 3, because that's our assumption. But here the minimum value will be 1, which is not good. So we cannot take 3, and start will be as it is. And similarly for 2, we can, I have explained you 2. Now for 1, how, like, what is the nearest smallest value to 1 on the left side? We don't have any value, so I will say that okay, starting from 0. And what is the nearest smaller value of in relative to 1 on the right side? There is no value, so we will say the whole array could be taken in part of for 1, because 1 is the minimum value out of all them. So how we can solve them? So now this problem is divided into 2 parts. So first will be to find the total number of subarrays, and the second will be to find the nearest just smaller value than the current value. So first part I have explained you, that is the total number of subarrays, that is here. The second part is none other than next greatest integer. So next greatest integer, we usually use a stack for that purpose. So we have a stack which will have all the index, and then we have this array 3, 1, 2, 4. Their indexes will be 0, 1, 2, 3. Now we will be constructing an array, that is start array, which is going to have information about what is the start point for this ith element. And we also have an end array which will tell us or give us the information what is the end point of the ith element. So let's construct the start. In order to construct start element, we obviously have to start from or traverse the array from left to right direction, right? And for the end array, we will be traversing the array from right to left direction. Now let's build the start array. So in this stack, there is no element. So I will say that for 3, there is no start. So I will simply say -1, which is a representation that it can have 0 value. And for 1, we don't have any minimum element on this side, right? And I have stored the index as 0. Now 1. So index 0, that is that this is none other than element 3, right? Now 3 is, let's just give 3, 0. So I mean, in practicality, you won't be storing the element into the stack. You can only store the index, because then you can access the element. But I'm just for a visual representation, I'll be storing 3 as well. So now 1, and we have 3. Is 3 smaller than 1? Could there be a problem for 1? No, there is no problem for 1. So we will simply remove this, and we will have 1, 1. And the element that is stored here is -1, because for 1 we have not found any smaller value than the ith value, that is 1. Now for 2, what is the nearest smaller value on the left side of 2? We will consult stack for that, and because we made some assumption that stack will always have, on the top element will always have the smallest value, and if it doesn't, then remove that element. So 2, the smallest element is 1. Yeah, it's fine. So we store the index of it, that is 1. And at 4, and we will push that element as well. So 2, 2 is here. Now 4, what is the nearest value? So the top element, yeah, it's satisfying the condition. So we will put 2 here. So the subarray will look like this. That is -1, 1, and 2. So this is the start array, not subarray. And then we will clear the stack for end subarray. For this part, we will begin from this direction. So a point to note here is that if we don't match with the condition, then we are putting -1 in the start subarray, and it makes sense, because -1, and then you will increment the array and you will have 0, right? But in the end array, we will not put -1. Rather, we will put n value, the size of the array, because n -1 will be the last value if we have to access the index. So at index 4, at fourth element, index 3, We don't have anything into the stack, so we will push that element. This is the element and this is the index, and the value that I will have is n, because we have pushed the element and we haven't met with any condition that we are making an assumption of. And now at 2, what is the smallest value on the right side of it? We will consult stack. We don't have any smaller value, so we'll push the, we will obviously pop out the big values, and now we have 2 comma 2 as the small value. Again it will have 4 because the condition was not satisfied. And for 1, what is the smaller value? What is the smallest value on the right side of 1? The nearest smallest value. It doesn't have any smallest value, so we will pop it out as well because it was greater than the current value. And now we have 1 comma 1 as the smallest value, and for this side we also have 4. Now at 0, for 3, what is the nearest smallest value? It's 1, right? And it's on the top of the stack. So now we have this answer as we will have this as 1, right? Now there are certain sections that we need to create. So the formula that I have, let me copy it. Right, so this is the formula that we are going to use. And so what this formula says, that this is the I plus 1. Sorry, this is the I plus 1. I is the index of the, or the ith element index. And this is the n, that is the total number of arrays. So now from this start and end, I will construct these arrays and I will tell you what will be the final result. Sorry. Now we have some elements that we need to construct. The subarrays will have their own size, right? Let's say capital N value, and this capital N value will be equal to, this capital N value will be equal to the end of I minus of start of I plus 1, right? These are the total number of elements in the subarray. And so yeah, fine. So now we have these. So the n will be changed because for every subarray, the size of the array will be changed, right? Because we have index and we have start and end point. We have different start and end point basically. And another value that will change is I dash, right? Because if we are creating, so let's say we have 3, 1, 2, 4, and now I am talking about this array that is 1 and 2. So the indexes that it by default it has is 0, 1, 2, and 3. But in this case, the one which has the index as 1 is not 1 anymore. It's 0 and 1, right? Because the n value is changed, that is the capital N, and that is equal to 2. In this case, the n was 4, and the index, the I dash value is also changed as 0, and in this case it was I. So this was my main motive when I'm making these calculations. Now I dash value is changed, and I dash value will be equal to I, that is the index, minus of start plus 1 value, right? Start of I plus 1 value. So for we have 3. Now the elements that we have is 3, 1, 2, and 4, right? So let's construct these values. So for 3, n is equal to end of I and start end minus of start of I plus 1. So start of I is minus 1, that is 0, and end of I is 1. So this value will be equal to 1 minus of 0. So this will be 1. And n value for 1 will be, so this is end, that is 4, minus of start of I plus 1, that is 0. So this will be 4. For this value, that is 2, the end value is 4 minus of 2. So that is 2. and for 4 the end value is 4 minus of 3, that is 1. 4 minus 3, that is 1. Now we will be constructing I dash values. So I minus of start of I. So this was 0. Um, this is 0 index, right? So 0 minus of 0, that is 0. Then we have 1 minus of 0. So that is 1. Then we have 2 minus of this value, that is 2, that is equal to 0. And similarly we have 0 here. Now we need to construct these values. So the formula that we had was this formula. This is the I dash basically, and this is the capital N. And these are the total number of subarrays that you will get from this element, from these ith element. And now you need to multiply the array of I with the total number of subarrays that you will have, and that will be your answer. And you need to add them into an answer variable, and that is your answer. And another important fact which would be implemented in the coding part, that is you need to take the mod of 1e plus 7, 1e9 plus 7, that is 10 raised to power 9 plus 7. So I think the question must be clear now, and let's start with the implementation part. So first we need to create these vector that is left, that is start and end vector, and they will have the size as array dot size, right? And we have end vector, that is array dot size again. Now we also need a stack. For stack implementation I'll be using a vector only. And yeah, so now we need to iterate over the array. So the first case, if stack is empty, in that case do nothing, just left of or start of I is equal to -1, right? And then we'll push the element, but that will be done regardless of any condition, so we'll be taking that statement at last. And then we have else if array of, now stack dot top, which means stack dot back in vector, is, let's say, less than array of I. This is a good condition because we are using stack basically for this condition, that if the top element is smaller than that, right? So in that case start of I will be the top value, that is st dot back, right? But if there's a condition that the top value is not, okay, so back to the coding part, I have to attend a very important call. Yeah, so now when we are in the when the stack is not empty and the top element is also not the required element that we are using, basically we are using the stack for, then we will, because this says that the element or the index of the element on top of the stack has, or the let's say associates with a larger element, which should not be the case. So in that part we will empty the stack. Till then we will remove all the elements that are greater than the current element, right? So for that I will say st dot empty until unless it's false, remove the top value only if the array of st dot back is greater than array of I, right? Then pop the back element from the vector or the stack. And at last the left of I value. Now if the stack is empty, so if the stack is empty, then simply the -1 should be the value there, because this is a start index, and I have told you earlier that start index could have -1 values and end index will have the size value. Because we are +1, we are plussing 1 and we are subtracting 1 in the end part, right? And because if it is equal to yeah, if it is empty then -1, otherwise if it is not empty then st dot back will be the value. Fine. Now at last I will say st dot pushback the ith value, right? I think yes. So let me just give you this condition as well. I think this makes sense. And similarly we will have something similar for the right or the end array. We will start iterating from right to left. So I is equal to array dot size -1, that is the last element, and greater than equal to 0, and it's a decrementing pointer. And if stack is empty then push the array dot size into the stack, and this should be end. This should be start, right? Yeah. So if it is empty then simply have that size of the array into the end vector, and if we have a value that is smaller than the current value then simply have that value into the end as a top element. And if the index of the element of the on top of the stack associates with a larger element, which should not be the case, then we will again simply remove the element until we have, right, we will remove the element until we have a value. And in this case, if end of I is equal to st or empty, if it is empty then it should be array dot size, otherwise it should be st dot back, that is the top element of the stack, right? And then again we will push that element, but before that we need to clear our stack, so I will call st dot clear. Now we are done with the end. Now we are done constructing the end and start and ends vectors, which will be using, or which are like which are pointing, which for every ith element they will give us the information what should be the start of this array and what should be the end of this array in order to have the minimum value of all the subarrays. Now we are done with little maths part, and that is I is equal to 0, I is less than array dot size I plus plus. So first thing we will have is int sub. So this is the number, or let's say subarrays, right? The subarrays is equal to, so I will have a function total subarrays which will take the start of ith value and end of ith value and the current index. And I will also have an answer vector that is a long variable, or sorry, answer variable that is a long data type of long data type, and answer is plus equal to, now long into the array of I, right? Because I have told you that these array of I should be multiplied with this value, because these are the total number of subarrays which will have the minimum value as array of I, but the sum will be multiplied with the element, right? I mean the total number of arrays should be multiplied with the element in order to have the total sum of those minimum values, and they will be multiplied with subarrays. Fine. And at last we need to have a mod value, so that is mod, let's create mod constant mod is equal to, I think it's 10, okay, 1 is 10 raised to the power 9 plus 7. Then we have another function that is int total subarrays, and it will be an int start index, we have an end index, and then we have an I. So in this case the values that we need are, so first of all is the new n, right? And that will be equal to, as I have told you earlier, it's equal to end of I minus of start of I plus 1. And you can also check these values. I'm not going in detail with these values because these are kind of intuitive. So the end value minus of start plus 1, right? This is a new n, and the index is equal to, that is our I dash here, is equal to I minus of start plus 1, right? And then we will be returning the index plus 1 multi this formula, right? Index plus 1 multiplied by n minus of index. Fine. And we also need mod of this value, so this will be modded with this value. Fine. Now this will return the total number of subarrays. We have this value. We are also modding the answer. I think we are good to go, and let's return the answer. Okay, so there is a problem, and okay, so let's debug this code. What is the problem here? I think it's the duplicate problem, and but that shouldn't be there because we are popping the element out. Okay, I think for in this case we can have elements that yeah. So in this case, if we have equal elements, we can have them because they are on the left side, because we are having a start value, right? Yes, because we need the maximum start value so that we can have maximum value of our answer. I think now it will run fine. Okay, it is. Yes, and it is pretty fast. So I think, yeah, so I think that's good. Space wise, it's okay. Okay, yeah. I think my solution would be a little more descriptive and long because I'm dividing the problem in NGI and then counting the total subarrays having the minimum value. But I think it's very beginner friendly because this solution is not copied from the solution section. So yeah. Okay, so thanks for watching, guys. Bye.